In this video, I will be doing a review for the Chapter 6 of Geometry, and I'll be working through several types of problems in addition to trying to write down a list for you of what to study or perhaps some helpful hints. So I'm going to go ahead and start out with my first example. It says that the perimeter of a rectangle is 36. So perimeter of a rectangle is 36. I know that I can easily draw a picture really quick. And the ratio of the lengths of sides, so it says the ratio from length to width is 2 to 7. So I don't know the actual length and width, however, I can write the ratio. So this is 2x, 7x, 2x, and 7x. So this is my length, and this is my width. And so from that, I can actually add up all the sides. 2x plus 7x plus 2x plus 7x. And that, the perimeter is supposed to equal 36. So that's 4 plus 14x. So that is equal to 36 again. And 18x equals 36. So then I can actually solve, and x equals 2. So if it asks for the length, then I would go ahead and plug that back in. 2 times 2, which is 4, so that would be the length. And the width would equal 7 times 2, which is equal to 14. So they can either ask you to solve for x or solve for the length or width. I'm going to go ahead and now do a problem about the angles of a triangle. So it says the angles of a triangle come in the following ratios: 5 to 6 to 7. So if I have a triangle, I know that the ratio is 5x, 6x, 7x, 5 to 6 to 7. So if I add all three of those angles up, 5 plus 6 plus 7x, I get 18x, and I know that all three of the angles of a triangle on the inside have to add up to 180 degrees, so then I can solve from x there and get 10 degrees. So if they actually ask for the full value of each of the angles from smallest to greatest, I would plug 10 in, plug 10 in, and plug 10 in. So then I get 50 degrees, 60 degrees, and 70 degrees for my three angles. One of the other types of problems, this is still in section 6.1, that they cover are the geometric mean. Geometric mean. So what this is if you remember when you have a ratio a over b equals c over d, we actually end up identifying which ones are means and extremes, and we came up with this formula. The square root of the product of two numbers. So I get the square root of a times b. So if I were looking for the geometric mean of 4 and 9, I'll do 4 times 9, which is 36, and then I would take the square root, so the geometric mean would be 6. So you may actually have to calculate the geometric mean, or you might have to find which two numbers give you the geometric mean from a multiple choice question. Continuing on to 6.2, this is when we started setting up certain ratios. So for example, I have 7 over 2 equals a over b. So if this is true, then 7 over a would equal, and you might have a question mark on this side, so we need to figure out what it's equal to. So if I do 7 over a, it should equal, 7 over a should equal 2 over b, and that would be true. Alright, so this was identifying some properties. If 9 over n equals 4 over m, then 9 plus n over n equals, and this is your question mark, 4 plus m over m. So this was at the beginning of 6.2 on page 364. You can look over those properties and kind of see how these fractions and proportions are set up and exactly what you can do with them, which is helpful for when you get an example like this. So let's say I have a triangle and I know that these lines are parallel. I can have 15, 10, 24, and x. So I need to be able to set up a proportion in order to solve for x. So one proportion that I could set up would be 15 over 10 equals 24 over x. Or I could set up 15 over 24 equals 10 over x. Or I could separate the two triangles out, 15, 10, and then I'd have to add up 15 and 24, which is 39, and then this would be 10 plus x, and I could do 15 over 39 equals 10 over 10 plus x. In either case, when you cross multiply, in this case you would have to distribute that 15, but you're still cross multiplying. You would still end up with all the same values of x. So it's just setting it up in the beginning where you need to take your time and set it up correctly and move consistently. Another question that they might ask is, what's a scale factor between two figures? So let's look at a problem like that. So here is a similar problem. I've got shape A, B, C, D, E, and that is similar to shape Q, R, S, T, U, V. Keep in mind, this is a similarity statement, and when they ask for that, sometimes the letters might not be in exact alphabetical order, and they do that to you on purpose to try to throw you off. So if I'm looking for the scale factor, I'm just going to say it's K, alright, scale factor, from A, B, C, D to Q, R, S, T, U, V, I need to take A, B, C, D, which that side length is 6, over Q, R, S, T, U, V, which is 16, and then reduce it. So I can chop them both in half and get 3 over 8. That's going to be about it. If I reversed the question and asked from Q, R, S, T, U, V to A, B, C, D, E, then I would do 16 over 6 equals 8 over 3. So it would be 8/3 versus 3/8. So keep in mind the order. Order matters. Another thing that I have to do is, if they don't tell me that two figures, two polygons are similar, I need to prove that they are similar. And there are 3 theorems that we used. We used angle, angle, we used side, 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 and we used side, angle, side. So order does matter. That needs to be an included angle. So you need to look at the figures that you do have and what information they give you. So let's go ahead and look at a couple of examples. Okay, so in our first example here, this is example 1, I have 2 triangles, A, B, C, and D, E, F, and quite frankly, they look similar. However, I need to see if I have enough information. So right away, I do know that they have one angle congruent, and that's awesome. However, I don't have any other pieces of information and no other way of finding anything. I don't have any parallel lines. They aren't connected or overlapping. There are no vertical angles. So this one is not enough info. Not enough info. One other piece and I would have been fine. Alright, so let's move on to the next example. So I have three sides for each of these, so I would want to see if I could use side, side, side. Angle, angle is already going to be ruled out, and so is side, angle, side. Why I can rule those two out is because I don't have a single angle. So I want to see if I can set up any proportions. So I'm kind of looking at the numbers and I see a 36 and a 12 maybe. So maybe I want to do LK over HI. If I do that, then I want to do JL over GH. And if I do that one, I want to do JK over GI. And I want to see if this works out. So 12 over 36 equals 15 over 45 and 25 over 75. So I want to reduce all of these. So I get 1/3 equals 1/3 equals 1/3. So it actually checks out. So that is true. So that means I can use side, side, side. And right there is the reason why. They are all proportional. They are all proportional. Alright, angles have to be congruent and sides have to be proportional. So let's look at the third example here. So outright, do they give me any angles? No, not really. Do they give me any sides? But can I find some information? Sometimes we have to search a little bit. So I do have vertical angles, so that's one angle. I've got a check mark there. Alright, that's one of them. And I'm also given parallel lines. So if I kind of redraw to rethink this a little bit, I have parallel lines. Well, with one set of parallel lines, I do know that those angles, which if you remember, they are alternate interior angles, those are also congruent. So I know those ones are congruent. And if I use the other transversal, alright, this one, I know that those angles are congruent as well. So that's going to be a double, and that one will be a triple. So I not only technically have one hidden angle or two hidden angles, I actually have all three. So that means I can use angle-angle similarity to prove them congruent. So redrawing some things and sketching some stuff out, especially if two triangles overlap, just like this one, it is going to be helpful for you to figure out the correct proportions and to actually see, is it angle-angle? Well, I've got one angle. Perhaps it's side-angle-side then. I'm not sure. Okay, so I just want to finish out by doing a couple of final examples. So in this first example, I believe this was theorem 6.7. It was an angle bisector theorem. So what it said is if you have a line that cuts an angle in half, it creates proportional sides. Alright, so if I take x, so that's a side on the top triangle that was made, x over 9, so that's a side on the bottom, x over 9, so top over bottom, that should equal 18 over 24, top over bottom. This is what I'm talking about as far as consistency, and these two are on the same side, and those are kind of the opposite sides. So what we can do now is cross multiply and divide. I get 24x. 24x equals 9 times 18. And then I get x equals 9 times 18 divided by 24. And that comes out to a decimal, so 6.75. So I still want to get my answers in fractions in order to make Miss Hlebiczki happy. So let's see if I can just factor some stuff out. So I know 9 is 3 times 3, and I know that 18 is 3 times 6, and 6 is 3 times 2. So let's see how far I can break 24 down. 2 and 12, which is 2 and 6, which is 2 and 3. So I can start crossing some stuff out now. So 2 with another, oh, no, that's about it. So I end up with 3 times 3 times 3, which is 27, over 2. And if you know how to convert that back on your calculator, that's how you would do it, is you would press your fraction to decimal button, or maybe you have a graphing calculator and you have to press math, enter. Okay, so your next example was something very similar. It just involves a couple more steps. So I can set up a similar proportion. This time I'm going to do 6 over 4. 6 over 4 equals x plus 3 over x. So notice how I did this side on bottom, and upper triangle with the upper triangle and lower over lower. So when I cross multiply, I get 6x, and then the reason why I wanted to do this problem is when we multiply, I need to distribute that 4. So I get 6x equals 4x plus 12. Subtract 4x, I get 2x equals 12, and x equals 6. Alright, and then in my last problem, I am given this. I'm given this, so if I'm given it, might as well use it. So EF over DF, so EF over DF is equal to FG over FH. So I currently don't have EF, and that is exactly what I want to find. So I'm just going to leave EF there, over DF, which is 14, over FG, which is 6, and then FH. That's the entire side. Don't be tempted to put that 10 there. The entire side is 16. So when I cross multiply, I get 16. You can rename that as, an x. That's fine. 16 times 6 times 14. Then you get x equals 6 times 14 over 16. You can multiply that out and then reduce that fraction, which is equal to 5.25, or as a happy fraction, 21 over 4. Okay, if you guys have any questions or need additional help studying, please feel free to see me tomorrow morning or send me an email.